If the first panel would go ahead and take their seats. Morning, David. Good.
Had a great day in Texas.
I hope so.
The kids have abandoned me totally.
Have they?
Yeah.
Yes, sir.
Morning, Chuck. How you doing? Morning. Morning.
So Philadelphia is such an antagonist. Well, that's the only way that you guarantee you
we
don't
meet again.
duplicate.
We meet again. Yeah, right. We keep meeting. Right.
And you know, it would be interesting if that requires you to do a full assessment of core capabilities across all of these.
Простите меня, потому что я здесь путаюсь в этих знаменах.
Давайте я вам помогу.
Вот, спасибо большое, потому что я вчера чуть не упала. Вы меня вчера поддержали здесь. Я чуть не пряталась.
You and me, I mean a pen.
Oh, you mean a pen?
In the NSBRI.
Good morning.
You know, you saw that their university sponsoring this event.
Yeah. Not pen?
MIT and many of the other
Good
consortium.
morning.
Yes, that I missed.
Slam dropped off of the radar completely.
No,
Galton?
I don't think so, because I've gotten him to do several things. Breaking the log jam at Penn is what he did.
I understand.
Are you okay?
That's okay.
You may not take the flag home with you.
Thank you.
Just knocking down the barriers and working more, I'll say casually, just so you know. That's not everything requires a space activity and everything else.
Well, good morning. We have the first panel already seated here, and we'll go ahead and get started. We're very fortunate, I think, to have Bill Gerstenmaier as our moderator this morning. Bill, of course, is the Associate Administrator for the Office of Spaceflight and brings a great deal of experience to that job, and I think has been doing an outstanding job there, and in all his previous positions is in the control center over in Russia and also in the shuttle program and in the space station program. So he brings a great background to that position. So let me turn it over to Bill.
Thanks, George. We have a great panel here today, and I haven't told them what we're going to do, so we'll see how well they collaborate and how well they work together as a team. So this will be a real-time demonstration on their collaboration skills. So there's 11 of them, so I figured if they would all talk for about 5 minutes, that ought to give us about an hour, and then that gives us about 45 minutes or so for questions, which I think would be very good. So rather than just letting them all talk on their own, I've learned this somehow throughout Space Station. I have to give them a little bit of guidance, not much. So the first guidance was 5 minutes, and so keep it about 5 minutes. The second guidance is we're supposed to talk about collaboration. And so I think there's a couple things there that I'd like you to think about is from your own perspective, you know, if you've worked in ISS or you've worked in other adventures in the space program, what things, real things, should we be doing to improve collaboration? So think of it from kind of a practical standpoint. What things could we be doing better from your perspective from a collaboration standpoint? So think of objective, definable things, not philosophical things, but more definable things. And then also talk a little bit about some of the hurdles that are there to overcome. And then maybe you can't talk just about the hurdles, but you also have to talk a little bit about how you remove some of those hurdles. And I think we heard some great things yesterday about collaboration, so you ought to think about, you know, what we heard yesterday from the luncheon speakers and from the other folks tomorrow and start. So with that, I think we'll just start down here, and we'll kind of go left to right with about 5 minutes each, and you can talk a little bit about collaboration and what you see as impediments to that and ways we can do more collaboration in the future. So we'll begin here. Thank you.
Thank you. Good morning, ladies and gentlemen. Yeah, the collaboration is much talked these days, and I think cooperation in the International Space Station or other space programs are becoming more and more important. And I've just talked that yesterday that we didn't have the experience in ISS, but I do hope that we'll have chance to be one of the members in the ISS, because I think since it's international, so China should be one of the member in ISS in future, I think. And I noticed that a lot of colleagues from the colleagues from the human space fields that welcome us to participate in such kind of international cooperation field. That for in China, that a lot of people must notice that in futures China will launch his own space station in about maybe 8 years, around 2020, I think. So that is a date that the ISS should be maintaining its life, I think. So I think that Chinese space station in the future should be an international one, and personally, as a scientist, I welcome that international partners to participate in our space station and make it an international one. Thank you.
Okay, thank you very much. Okay.
Good morning, everybody. My name is Jean-Marc Comtois. I represent the Canadian Space Agency. It's a tall order that Bill gave us, and I'll address the question from a small agency's perspective. Being a small organization, it's not necessarily bad. I think the structure in place makes it easy to implement changes, but it also comes with limited resources, whether they're financial or human resources. Yesterday at lunch, we've had a very inspiring talk where collaboration was based on, needed some qualities that we needed to look for to collaboration. And I retain that there's only 2 qualities necessary. One is trust and the other one is altruism. Trust, because that will lead to openness, sharing idea, and altruism, because it will also lead to being generous with your time, generous with your ideas, perhaps generous with your money, which is a limiting factor nowadays. So from a CSA's perspective, we need to really look at how do we manage our limited resources. So we need to collaborate and not duplicate. And one of the best approach to not duplicate is to have a coordinated approach, a roadmap, so to speak, as all together, all the scientists, all the nations working together in a given roadmap. I think there was a great effort to this through the Global Exploration Strategy. The essence of that document hasn't changed much, despite the changing directions that some programs may have taken. And that's an example of how we can collaborate. I've had the opportunity of talking with Jeff not too long ago about the collaborative human risk forum that he's put together. And I thought it was a great idea to share information, to bring us all on the same wavelength. However, I thought that we need to push it a bit further. And the concept of different groups owning a risk. I thought was a good way to move forward. To own a risk doesn't mean that you necessarily resolve the risk, but you engage yourself in trying to come up with mitigation strategies through collaborative effort, through funding and so on. And that could very well also be a international endeavor. It doesn't have to be a national endeavor. The other element that I think we need to work on in improving collaboration, but also ending in improving the quality and the amount of research that's done on the ISS is perhaps streamlining some of the certification process. It has become so difficult, and I understand why certification is required, but it's become so onerous that it is also an impediment sometime in moving forward. It takes so many years to bring good science up to the ISS. And one of the best news we've heard yesterday was the work that's being done on export control and how this is going to hopefully be changed in a way that it will facilitate communications between the different nations. Thank you.
Thank you. Thank you. Good morning. I'm Jeff Davis from Space Life Sciences here at the NASA Johnson Space Center. This is a nice opportunity for me to maybe recap some of the things we talked about yesterday and tie them together and build upon what Jean-Marc said. The way we're approaching the long-duration human spaceflight, as you know, is we've put together a portfolio of human system risks, and we've identified about 65 now. That number fluctuates up and down a little bit as we continue to consolidate and integrate the risks, but that really defines the portfolio of work, if you will. The way each risk then is approached is in a vertical fashion from a standard right down to a deliverable. And in analyzing then each risk, the work could take place at writing a standard or improving a standard. It could be about reducing the uncertainty, for instance, in radiation. It could be about, if you know quite a bit, it could be going right down to offering a deliverable. So we put a human system risk board together just a little over 2 years ago now to manage those risks in a deliberate way. Dennis Grounds and I co-chair that effort. It combines the operators and the researchers so that we get both communities together. And based on a comment at last year's Space Medicine Summit, we started the Collaborative Human System Risk Forum and opened it up to our international partners, and that started in January of this year. And that was really more in terms of information sharing about the risks, current status, where are we, what do we know, what's the evidence base. And I think it was at the first forum that Jean-Marc asked me if we could consider other partners, other groups owning a risk. And my first response was, why not? If they have that level of expertise and can contribute to that risk. I think the tie-in there would also be good because it would, the agencies would have to partner together to determine what their core capabilities were and where could they both benefit each other and not overlap and duplicate. So along those lines, another effort we talked about right before dinner last night, which was the proposed Human Health and Performance Center. That also gives us another forum to convene interested groups, not only the international partners, but other government agencies. I mentioned we've had contact with NIH, NIST, NSF, and we can invite in other academic partners and other interested groups. So I think we're approaching the collaboration in several ways. One is being open about our risks. The 65 risks I mentioned, we should have reduced to this risk format by the end of this calendar year, all stored in an information architecture database, and then we plan to also put them out in a format that could go out into the public so that we could get additional comments back about the risks. So I think there are several forums, there are several knowledge bases that we can use to stimulate more collaboration. So I think the timing of this discussion in this panel is very good. Thank you.
Right. Thanks.
I'm David Dinges from the University of Pennsylvania School of Medicine, and my only perspective on this is as an investigator who has projects on ISS, and we're on our 4th NEMO mission, and the IBMP's Mars 500, the 105-day, and we'll be in the 520, an analog study at Johnson Space Center. And desert rats and hot and Mars. So we've been doing this for a while in addition to our laboratory work. And I'm going to give you, there are plenty of you here who know the top-down view, the management view, I call it. I don't mean that in a pejorative way, but I'm going to give you the bottom-up field trench view from a scientist standpoint. We need, obviously, we should be doing collaborative research, let me say right up front. But there's a series of hurdles that scientists have to go through to ensure that this works. And the agencies generally know about this. And in fact, my experiences with NASA and NSBRI and IBMP have all been very supportive of this. Oftentimes, however, the timelines are not well understood. And the issue of collaborating with another scientist is a little fuzzy in all of this. And for example, typically the universities require full cost accounting. So if you call me up and say, Dave, would you be willing to analyze your data 7 other ways and send it to us right away? And then I look at my budget and say, well, that'll cost us $7,000 to do that. Well, who's going to pay for that? I'm not allowed to do that favor for you. Not at the University of Pennsylvania, not in my office on my computers with my staff. So who pays for that? So that, and you need, those of you not in the United States, you need to understand that. In the United States, every scientist is held to the penny full cost accounting to run a laboratory. What did you do this year? Et cetera. So it's very hard to just do favors. Sending data to people is not collaboration. That's not collaboration. Collaboration is they bring something intellectually to your discovery and you bring something intellectually to theirs, and jointly you do something. That's collaboration. So now, should we have a broader, though, plan that when the grants are funded, it's understood that some data will be shared with others? That you could do, and I think we've discussed this with IBMP about, for example, with some of the stuff in 520. But I think we need management to help us figure out some of these paths. The same thing applies to IRB, human subjects. Most countries have ethics committees or follow a standard ethics code, but we do have to jump through the hurdles of our individual countries. And we've worked very well. Igor Savalov has helped us do that with IBMP and make that work. But oftentimes, the amount of time it takes for management to get things in place leaves incredibly little time. Once they say go, and the mission's going to start here, and now you've got 3 months. You got to get all your equipment. You got to get through export control. You got to get the IRB done. You got to socialize the subjects. You got to instrument the facility. It is a fire drill. It's an absolute fire drill. And what I've noticed is it burns down my people. There's only so many trips. There's only so much stress. There's only so many things they can do before they start to melt down. That actually is a serious challenge. So we have to allow the timelines, whenever possible, to work through. I think the other thing is the logistics. This cannot be done without the logistics people being so critical. Again, I've mentioned Dr. Savalov, who's made it possible for us to work in this remarkable chamber that the IBMP has developed. But right now I have staff down with Lauren Leviton's BHP people at NEMO 14 who dive on the facility, help collect the data. You got to have boots on the ground, as they say in the military. You got to have somebody present helping. Now, there are a lot of people who do science in space that don't need that. The nature of what we do requires it. But usually you got to have these critical logistics people. And it's not just doctors and scientists. Believe it or not, it's translators. If the translations are poor, on text or explanations or anything, then you can get bad data. So you have to actually sweat the details right down to the finest point. And we have to do a good job with these things. Otherwise, we waste the precious money that exists. So my message is that that collaboration is feasible. We ought to be doing it. We ought to be looking for avenues. We need not only management structures to do this. Frankly, I'm not comfortable being contacted by a scientist in another country saying, send me your data. I don't mind if they contact me, but it's not me to say that. I would like the organizations who funded me to make that decision, and then I'll release it as they say it should be made. I think we need structure for how we do this and at what level we're going to do it. So we have actually worked it out. The collaborations are occurring, and they're pretty good, but at the same time, we could probably do better in this area. Thank you.
All right, great. Thank you very much.
Good morning. I'm Chiaki Mukai from Japanese Space Agency, and I would like to explain about the recommend two things. basically the one thing, we have to change the idea, the approach of doing this collaboration. And in that, the content, I would like to explain about the two things. One, change in the way or approach that what we do amongst the disciplines, or the life science or space medicine area. And the other change is that the keyword for us is the space medicine and also the ISS utilization. So space medicine itself needs to collaborate with the other field like Earth observation or space observation, etc. So I would like to explain the two things, those two changes that I would like to recommend. The first change, the way that we approach to collaborate amongst the life scientists, was so far, based on my experience during a space lab with working with John Charles, the many people from this audience, so far the collaboration was a kind of agency-oriented or resource-oriented forced collaboration to the scientist. So the change the paradigm or model from the forced collaboration to the scientist, from the scientist-oriented collaboration. So that is the way. Of course, quite a lot of hurdles that we have to overcome. But yesterday, Inessa mentioned that the Bion is the best, the very good the model for the collaboration. And generally speaking, the animal experiment, including tissue sharing experiment and Bion, they did a very good job. And then maybe one of the way that we do for the human experiment is to adopt these models, like maybe choose only a few number of the main experiments and then filled with the secondary experiment which can maybe fill up the gaps, and then to ask the scientist, like if you collaborate with these other scientists, 1 + 1 becomes more than 2. And then unless the scientists have some benefit to collaborate with other people, that the relationship, the good relationship will not last long.
Exactly.
So that's how I think the people, I'm also work for the agency, so the people for the organizer or people working for the agency needs to change the way of thinking to better serve for the scientist community, so that the scientists will be beneficial by the collaboration. That's one thing. So maybe just one example was the Bion and also the tissue sharing, but that is one way that we have to change it. The second change that I really would like to propose is, maybe this is more the main of my point. As I mentioned, that the space medicine and ISS utilization is our issue that we really seriously think about it. So rather than collaborating inside of the space medicine field, let's try to collaborate with other field. Like for example, JAXA, Japanese case, our the keyboard module, our facility has a special feature, like an exposed facility we have, and that exposed facility, we have several devices, like since I started learning recently, so I don't know much about it, but of course, some of the device can examine about the space environment data acquisition equipment for helping astronaut health. And then these information include solar radiation, radiation belt, and space debris, and micro meteoroid, and the galactic cosmic ray on the plasma, atomic oxygen. So this is the environment to measure for the space. And also, we have to monitor the Earth environment, because space medicine is basically the ultimate preventive medicine, because the astronaut is a healthy people, and we don't want astronaut, cosmonaut becoming ill. So it's a pretty much preventive medicine, as well as environmental medicine, public health, and then the community hygiene. So my point is maybe collaborate with the Earth observation team and also the space environmental observation team to develop a big system so that the space medicine and also the ISS will be the integral part of that big system. And as I mentioned yesterday, ISS can be a manned good observatory station, and then the cosmonaut, astronaut can be a wonderful observation members to help not only astronaut, cosmonaut health, but also the health of the Earth as also the people living on the Earth. So my message from my the summary of my message is change the paradigm to work together amongst the life scientists, and also change the idea, not change, but expand the field to collaboration with space medicine, with totally different area.
Okay.
That's what my message.
Right. Great. Thank you very much.
I'm Ann Kennedy, and I too am a professor from the University of Pennsylvania, and all of those hurdles that David Dinges mentioned also apply to me. I'm here today speaking as a radiation effects team leader for the National Space Biomedical Research Institute. I believe the International Space Station should be a highly integrated team working together on common goals and common protocols. As many of you heard at this, certainly from Amy Cronenberg and Marcelo Vasquez, the radiation world has worked as a team from the beginning. And they work very well as a team. In the middle of the night, you find people sharing things. At your accelerator time, you find the physicists helping with the animal blood draws, and the people who work with nematodes helping to put the animals in boxes. And it basically doesn't matter what your title is or what you're supposed to do. When something needs to be done, you help to get it done. As one of my people has said of accelerator work, it's like being out on a raft in the middle of the ocean and you've forgotten your oar. Many will share their oar, but the question is whether they will share themselves. Many of the things that need to be done in the near future require people and parts of themselves. And an example is blood samples for pharmacokinetic studies. We will need countermeasures for radiation exposure, but we know little about the distribution of drugs that will help in the radiation arena following or before radiation exposure. We have to know the timing of the drugs and when they're getting to the organs that they need to get to. I have just completed a 7-year pharmacokinetic study at the University of Pennsylvania with people in clinical research units giving their blood for the many times during the first 48 hours and up to a month after exposure. And how do we get people to do that? Well, money does it there. That apparently is not going to work on the International Space Station, but ideas will. Everyone has to buy into the idea that they are working on a protocol that will help them and their ability to survive on the International Space Station. Engineers can see, I would think, how it's going to help to know if the drug they need is going to get to the place it needs to go to help their symptoms or their long-term effects. So we need people to work together. We need them to share ideas, equipment. We need them to share everything, and that certainly includes the protocol and common goals of what they're doing. And as Inessa has said many times here, we need to share ideas, we need to share data. Well, now there's a huge problem in the astronautics community as I see it. In America, we theoretically can get information about astronaut health through the longitudinal study of astronaut health. It's like writing another grant proposal to get in there, and the likelihood is small that you will end up getting the data you need. And often the data you need has been so laundered that it is no longer appropriate for your needs. It strikes me at this point, when we have a good many needs, that we need to be sharing the effects of our astronauts with the people who are trying to help them. And this is not just Americans and our way of doing things, but I assume around the world it's an issue, and we have to begin to share the problems and share the way to develop countermeasures for those problems. I've gathered from talking to astronauts that one of the big issues is the little stuff, like who's going to wash the dishes. Well, I've seen in my own laboratory that for those who don't contribute to the SCUT activity, as it's called, it brings about enormous problems, dealing with the psychological problems that not sharing in the tasks that need to be done bring up. There has to be someone in charge who says, you have to clean up your own dishes right now, and they'll do it. And that basically doesn't come about with a number of people representing many different countries and cultures and dealing with things like the SCUT issues in a fair way. So we need to get the group working as a team together on all the things that need to be done. And common protocols would help that. If everybody can see the ideas of what they're doing and what they need to accomplish to get those tasks done. So we need a buy-in from everybody in this, and how to accomplish it, it's not happening now. We need to do something to change that. Now, in conclusion, I'd like to read you the conclusions from last year's discussion on this topic, which is discussion group A at ISMS 3. There was agreement that a universal standard platform of tests for physiological assessment should be adopted. The pre-, in-, and post-flight evaluations would build upon the currently used and internationally agreed upon medical evaluations. The international scientific community should come together in collaboration with the medical community and determine the metrics by a given date. A major review of medical data is needed to determine what is currently known from ISS missions. Going forward, it is desirable that crew involvement and consent be shared internationally. There are ISS opportunities and needs concerning international cooperation and coordination. Common equipment and resources, scientific, medical, aboard ISS for use by all crew. Universal protocols for countermeasures, consistent reporting on use of countermeasures, organizing and structural complex crew activities, 3 to 6 person crew, off nominal events. As inclusive international joint working group, we would serve as a scientific board for research, should be established in the near future. There are lessons learned from other boards about how this should operate. Cooperative research would be addressed at multiple levels, for example, discipline subgroups. Stakeholders include the international partners, operations personnel, crew, physicians, basic researchers, translational researchers, and commercial participants. Your turn.
All right. Thanks for the reminder of what we should be doing.
It was a wonderful summary. We really did a good job.
Then this finding this year will be to implement what we said we were going to do last year.
Right. That's exactly true.
Vanessa, go ahead.
Okay. Good morning, everybody. I'm Vanessa Kozlowska, and I'm rather like on the line, continuing talking about this collaboration, starting from previous year and now continuing. And I would like to just to explain why it is so, why I'm taking this so hot, because the Russian history of space flight, it is history of collaborations. Russia was having collaboration right from the very first flights. We don't know how to live without collaboration. We cannot find actually country who didn't collaborate on our stations, on our biosatellite, and so on. And therefore, all this discussion how to overcome the selfishness of scientists and sometimes difficulties of bringing them together, it is not that area in which I have any difficulties, because just believe me, let me give you an example. I come back to Bion. Dr. Gazanko suggested to start international project on Russian biosatellite, which was not existed at that time, but just we start and we suggest, he said, to have it as an international platform. Look like today, like ISS, yeah. But after that, it was broadly announced, everybody was welcome, no barrier were put like, give us the suggestion in Russian language and in this particular form with this particular cultural approach, just give us as it is normal for your country, for your normal life, and so on and so on. And after that, when the application came, the international board was created who consider all this, and from that time on, until 96, from 73, we flew 11 biosatellites. And this biosatellite, believe me, that was no arch, as you say, is in English. Not only in species, because they were every species were represented there, from Drosophila to monkey, but it was also no arch of nations. From states, on board of Bion, in the project which we are going there, participated about 40 teams from 40 universities. And there was no problem. And the friendship, real scientific friendship, which was started there, it was for the whole life. Like my closest friends, my closest friends are Reggie Edgerton and Bernie Cohen and Manning Correa, and ask them, they will tell themselves that I am their best friend. No, that's no problem, believe me. I don't believe in about any problem in between scientists. Problem comes from the other side, not from that scientists couldn't find the common platform and how to share data and how to publicate together. No problem whatsoever. Believe me, it is like, could you imagine from 70s up to now? And it is not just Chiaki for animal studies, not at all. Because our Mir station was another Noah Arch. But, everybody flew Mir station in joint project, not just flew with their own, bag, not at all. In joint project. And they were not hard feeling from any side. My best friend, again, from JC people, Bill Reschke and Jacob, and that is forever. And even those years when we didn't have already agreement on sharing and so on, we continue. And nobody could stop us because we are interested in exchanging of ideas, exchanging of results, because we are interested in going forward. I don't believe that, scientists are so selfish that they would rather sit here, if they would be suggested to have benefit of contact with the other people who also have idea, and so on and so on. I agree with you that, of course, if somebody will put on me, to work with somebody whom I don't consider as an interesting person, I wouldn't do it. But when you make the program, you escape it because you see immediately. Just a short joke. When we selected monkey for flight, monkey cannot fly by alone. They are communicating. That was, they cannot live just by themselves. So we had to sell 2 monkeys, but we have to select them. It turned out that some of them compatible and the other not. But I cannot ask monkey how she likes, whom she likes here, you know, among 14 of them. And what we have done, we put them for the night in chairs, but on long chain. And when we come in the morning, here they are. Two sitting together, talking, and the other two never together, and that's it. So the same with scientists.
I like that.
So I am very grateful to Anne that she had read today, because we had this discussion last year also. And I was talking already so much yesterday and day before yesterday about this cooperation. And now you have read, everything is in here, and my feeling is better than discuss how to do it. Let's start. Let's start, and don't have, put your fear out, you know. That's not the problem. Believe me. Just maybe let's be brave and start the program. Like Russians were brave and started the program of Bion. I always like to express my great respect to Dr. Gazenko. One small secret, why he did it. He did it because he believed that space should be international. That's first. And at that very time, USA people had very difficult time because of failure with Bonnie, with monkey. And Congress was always ready to close completely biological study up there. And then Dr. Gazenko, I just know it very well, and Dr. Gazenko said, okay, we will open international study, we will invite American, and we will save the community. So I would say again, I don't see any, of course there are obstacles, but they are always there, not only in cooperation. When I'm working at home, I have obstacles. I see my director here, and I know that I have obstacles. But you know, but we work through all our life this way. But if we know that it is necessary for our success, that's no problem.
Okay.
Thank you.
Okay, great ideas. Okay, next.
Спасибо большое. Доброе утро, уважаемые коллеги.
Good morning, dear colleagues. My name is Tunsev. I'm also from Moscow, from IMBP. And during the latest 5 years, I've been working at that institute as a chief of the Department of Scientific and Technical Relations. At the same time, for many years prior to switching to that position, I was the head of the scientific laboratory on medical biological extravehicular activity of the cosmonauts and astronauts. And I'm continuing work as a deputy lead of the Russian team that is responsible for the EVAs that are performed by the Russian segment on the International Space Station in Russian spacesuits. To answer this question is simple for me because Professor Kozlovskaya already gave the answer, but the question that was asked here by the moderator, I should divide into two categories. Performance of flights, space flight research is one, and second are challenges during the performance of operational medicine. As far as operational medicine or real-time medicine is concerned, I'm related to directly to the flight support. I worked with the astronauts. And I think I must say that we have big differences in this area, even though we have a lot in common as well. On the ISS, there are two types of protective individual equipment that are designed for the same purpose, to support safe and effective operation of humans in space. This is the first type. This is the American space suit for EVA. EMU, and then the second one is the Russian spacesuit, Orlan. But the thing is that the technical specifications of each of those spacesuits are very different. And in general, it doesn't allow for the standardization of approach to that particular protocol of preparation for the astronauts and cosmonauts for EVAs. Even for the protocol that concerns separate subjects, separate medical issues. And so, along with our United States colleagues, within the working group MOP, we've been revisiting those issues many times. So far, we came to an agreement that in those cases where the priorities in guidance and control of space flight, and priority is also safety of the EVA operations, then later the priority switches to, or is shifted to that entity that owns the spacesuit. And so, therefore, the Mission Control Center, Houston Mission Control Center is responsible if it owns the EVA, and then in the opposite case, the control is transferred to our Mission Control Center. When Orlan spacesuit operation is performed, then the Mission Control Center Moscow is engaged, and in that case, the priority on medical and technical support is relegated to our group, to the team of Russian specialists. So far, this is the situation, and it will continue existing until there is some common joint project for the creation or development of some sort of standardized or unified outfitting. It has to be standardized. The preparation system the training system has to be unified, standardized, and this is a great challenge which we are facing, of which we are aware. We are concerned about that. However, we work very closely with our international partners, and when our international partner participates in operation using our Russian spacesuit, then the evaluation of the state of the health of that person is carried out with that person's involvement. He participates in his own health assessment. The country that participates in EVA is involved, and also the medical parameters are measured appropriately. And this is the operational involvement to which I have direct tie. As far as the scientific research is concerned, as a manager of the Scientific and Technical Relations Department, along with my colleague Kozlovskaya, we do not have any major issues. So therefore, it appears to me that all the issues are resolvable, and I think that in such an efficient form they can be resolved. Similar to this one, like bilateral, a format of bilateral working groups and a bilateral working agreement is very efficient. And this, for instance, concerns the working groups of subjects of gravity and so on. And the Russian team is headed The American team is headed by Mr. Benjamin Newman, and the Russian team is headed by. And those meetings are conducted annually. The latest meeting was conducted in June of last year, and they summarize everything that has been done. The assessment is made of the current status, and the concept is adopted for future strategic flights. Then the complexities are evaluated, challenges, and the ways of implementation of various program landmarks. Many of you probably know about that, but our particular Institute of Life Sciences is a leading organization that is responsible for the medical and biological manned flights. We, at our institute, we have gathered many years of experience and practice, especially our second working group, where the scientists know each other very well, are familiar with one another. They meet often, and they are a very good example of efficient work. We have a great working relationship with our colleagues from Germany, for example. This year, literally upon completion of summit, the next day we're going to have a next meeting, bilateral meeting of TLR and MPP on life sciences, space life sciences, where we are going to summarize the status of activity that has been done by both sides for the past year, and then we're going to evaluate the status of the project that is work in progress, and also we're going to discuss an interesting scientific research. In addition to that, they exchange their interesting ideas about future prospects, and we exchange ours with them, and thereby we try to expand that sort of activity. And I have also worked with some of your other colleagues, and I must say that most contacts have been fruitful, and I would have to name all the representatives of all the space agencies and all the partners with whom I have collaborated. And in addition to that, we're also working with many representatives of scientific circles, academic circles from the United States, Japan. We have many contacts in Japan, South Korea, and so on and so forth. So thank you.
Thank you. Michelle? Do we have a mic that...
My name is Michel Tonini from European Space Agency. I am the head of the European Space Center in Cologne. And for us, the collaboration and cooperation has been very positive. Since the beginning, we flew in space. We had about 40 space missions, half of them with Russian and half of them with NASA, with the American. And this allows us to have a good knowledge of both systems and to be very, very easeful in terms of cooperation. We can deal with both countries in a good way. And we have always tried to be not on one side or on the other side, but right in the middle. And that was good. In terms of crew for astronauts, we have, as you know all, we have 1 IGA and 5 MOU. And this is the basis of the cooperation on ISS for crew. And this works well as well. We have a regular meeting like MCOP or MMOP or other panel. What is important in terms of cooperation from my side is a good communication. And it's very important that we have a regular meeting with all the partners, and every time there is a problem, we have to raise a problem and to talk about the problem as soon as possible. We don't want to let a problem going and without any solving resolution. So what I try to do is, as soon as we detect something going wrong in terms of collaboration, we contact our partners in order to try to solve them. And this is improving day after day. I mean, the role of ISS has really improved all this cooperation. In terms of cooperation, also a positive way is that we are a small partner. ESA is a small partner compared to NASA and the Russian. And I remember the first flight we flew as a payload specialist, and even it was difficult to fly as a payload specialist. But we gained the trust from the big partners, and from payload specialists, we become a mission specialist. We did important tasks like robotics, robotic operation, EVA operation. We even had last year the first time a commander of the space station, on ISS for 6 months. It was a European astronaut. So for us, everything is building positively, and it's really important to have a trust relationship, recognize and to make no mistake and to discuss all of that. What is important as well is in Europe, human space flight is a very special case, sometimes criticized by many people, especially by the scientists, because it costs a lot of money. But recently, there was a treaty signed and put into force, which is the Treaty of Lisbon. This treaty is the new base of the way Europeans want to work for science, for development of Europe, or for education and everything. And space program is one of the main topics. Today, European Union has a right to have their own policy in terms of space program. So we have the European Space Agency in one side, we have the European Union dealing with space in the other side. So there are many aspects of space work, but one of them is International Space Station, human space flight. And on the human space flight, the most important thing is the success of collaboration and success of cooperation. So for us, everything is positive. And again, it relies on a trust, on a good communication, and on a transparency in the communication. Thank you.
Okay. Thank you, Michel.
Good morning, and thank you for the opportunity to be part of this panel. My name is Jeff Sutton, and I'm the director of the National Space Biomedical Research Institute. And the perspective that I'd like to bring this morning to this discussion has to do with my role as a Science Institute director. And I think that to address the question as to what concrete actions and items can be done to strengthen collaboration, I think that one of the things to keep in mind is that science institutes really can offer a lot to cooperative endeavors. Scientific institutes work at a level above an individual university, but below the level of the government, and that there are certain attributes that science institutes have that can really foster collaborations. And we've had some very nice interactions, we being NSBRI, with the international community. We had an excellent visit to the Astronaut Center of China at the invitation of Dr. Chen. What I'd like to do is to talk a little bit about the relationship that has existed and is continuing to evolve between NSBRI and IBMP, to give some examples of opportunities that have arisen, of some of the hurdles that have presented and how we've overcome those hurdles. And again, this is by way of example. There are other examples as well. And I think it's pertinent to the types of cooperative research that can go on at the International Space Station. So looking at the 105-day study initially, there was an MOU between NSBRI and IBMP. What we wanted to do was we wanted to foster scientific collaboration between two science institutes. And so one of the first things that needed to take place was that the directors of those science institutes needed to come together to make sure that they had a similar vision. So I had very nice and very grateful for excellent discussions with Dr. Goryev and now with Dr. Yushakov. I think what then transpired were discussions within the United States between NSBRI and NASA. So we've talked a lot about trust between individual collaborators and trust internationally, but one of the things that needed to occur was an evolution of the relationship that NASA and NSBRI have, and it's been extremely productive, and I think many of us have been very pleased. But there are questions that arose that we did not know the answers to. For example, NSBRI sponsored, in collaboration with NASA, 3 investigators to participate, U.S. investigators to participate in the 105-day study. Well, when it comes down to contractual relationships, do you need a Space Act agreement for a science institute to collaborate with an international partner? We didn't know the answer to that. So we had some discussions with Johnson Space Center and with NASA headquarters and determined that the cooperative agreement between NASA and NSBRI sufficed for NSBRI as a science institute to enter into an agreement with a science institute from another nation, in this case Russian Federation. There was a need for more paperwork on our side because there were federal dollars that were going outside the country, but we learned what those reporting requirements were, and we also learned that it was very important to engage NASA in this cooperative activity. So we're very pleased with how things progressed. And then came the 520-day study. Now, it turned out in the 105-day study that NSBRI was allowed to use federal dollars because the ISS has there's an exclusion for federal dollars that can be used under as an exception to the Iran, Syria, North Korea Non-Proliferation Act. But with the 520-day study, that is not the case. And the reason is that the 520-day study cannot be argued to be an analog for ISS, 6-person ISS, because the duration exceeds an ISS mission. So that posed a hurdle. And the way in which we were able to overcome that hurdle, again with discussions with NASA, is that if we went ahead and NSBRI entered into a contract with IBMP, could we use non-federal dollars and have that piece as a possibility of having a contract go forward, with federal dollars being awarded to a U.S. investigator for their participation? And it turned out that the answer was yes. So this is an example of a hurdle that existed, a solution that was worked and has successfully been implemented, and is an example of how a science institute working at a layer down from the government can do things that the government cannot do, namely raise non-federal dollars and use those federal dollars for an important contract. And the implications are really quite amazing. It allows the United States to participate in a very important international study with Russia, China, as crew members, and the Europeans. And so my message again is one that I believe that the Science Institute collaborations offer a real opportunity to enhance already excellent collaborative arrangements that exist as we go forward with ISS and other projects. Thank you.
Thank you.
Thank you, and thank you for giving me the opportunity of being here right now. I'm Livio Narici, and I'm an international user of the International Space Station. I've been working in I'm a team leader, and my team has been working in the U.S. Modulus, in the Pierce Modulus, and before that in the Mir station. So probably what I would like to do here is just brief comments to add to what I've already heard, and I agree with everything has been said right now, up to now, from the international standpoint. It has been said yesterday that we collaborate much better in space than on ground and on the Earth, and I probably have to agree with this. So, and actually the ISS has been built with a strong international effort. But I had the feeling from the experimenter's point of view that this effort stopped somewhere. So, for example, why don't we try, and this is probably a dream, but why don't we try to make the International Space Station a single house, not a multi-property. This has a strong research rebound because, for example, my experience is that if I had to perform the same experiment in a different modules, or even in the same modules but under different agencies, I had to produce, duplicate, triplicate enormous paperwork. So this is something which slows down research, collaboration, everything like this. So the best way to approach this problem, my dream, I understand it's a dream, is to have a single entity to which the researcher teams have to talk to perform experiment in the International Space Station as just one over agency entity. So actually, if an experiment is going to be better performed in some part of the Russian models or the Japanese models or the US models or the Columbus models, it will go there and not the other way. There won't be duplication, there won't be absence or not understanding of what other people is doing if there is a single bucket where everything is going. Now this reminds me another thing that I already mentioned yesterday very briefly, that the funding problem. We just heard that there are ways to go around the funding, international funding problems, and I'm glad of it. However, what I know that, for example, from my experience again, but only for experience of my colleagues, research and collaboration, international collaboration, has been strongly slowed down because of the lack of the possibility of having funds out of the same grant, in a sense. If a team from Europe, one from the Russian, one from the United States, wants to perform an experiment, and they want to collaborate the way we heard beautifully yesterday, they had to triplicate the effort in a very synchronous way to get the funding for that experiment. Now, synchronous way in this kind of business is almost impossible. So what happened is that many occasions of international collaboration are lost. We must find out a way to get common funding, to be able to give funding outside the borders of each agency. So I would say to make the International Space Station, this could be the first step, of course, the International Space Station. We shouldn't stop there. But anyway, to make the International Space Station, as well as all the space, within the border of each country. So at that point, there won't be any more problems of this way. And for example, we will be able to mitigate those export problems that we have been talking yesterday, maybe not to solve, but to mitigate them. So these are my small two, comments about this. Thank you very much.
Great. Thank you very much. Took lots of great notes here. So let's see if we have some good questions from the audience. So why don't we go ahead and maybe see if we got some questions. Back row, John Charles.
Good morning, everybody. Thank you. My name is John Charles. Thank you for an excellent panel discussion. I have two progressively heretical suggestions to make, and perhaps Dr. Dinges can mentor me on some of the aspects of science. First off, in this discussion in which we universally acclaim the benefits of collaboration, how does one allow for independent confirmation of investigation results, which will require duplication by different techniques to provide the same answer? And even more heretically, is there no role for competition in spaceflight life sciences research anymore? I remind you that competition was important in the earliest years of the space effort. Competition between the US and the Soviet Union produced many benefits, of which we're still taking advantage today. Competition was important in the X Prize. Competition is important in these centennial challenges that NASA funds. Competition was important in the Human Genome Project. Do we do competition in space life sciences research?
Okay. Two good questions. Yeah, you want?
So, John, I would agree. In the United States, our model is one of competition. The idea is that the taxpayers' money for research should go to only the most meritorious research ideas, and we use peer review to sort of select those. And it's served us well. So any collaboration we would do with any other entity, a natural question in the back of my mind is, did the work that we're going to do, that they're proposing, did it go through a peer review? Is this did other scientists say, yes, this is the worthy thing to do? And then the issue of competition driving excellence, replication, is actually a fundamental criterion in science. There has to be some independent confirmation in some other way. I think that can still occur within collaborations, but there is a risk when when all money is vested in one study collaboratively to answer a question, and it may turn out the snapshot answer you get, for whatever reason, doesn't replicate later. So I think that's one of the reasons, though, the way around that is a lot of the science is working on monitoring devices, smart technology. And there's a lot of effort, I think, in all countries to come up with technologies that can be on board or be used to assess the status of astronauts. And that gives you an opportunity to replicate within and between people over time if you have measurement on board. And so I think we handle that way.
Anyone else on the panel? Yeah, go ahead.
Thanks, John. Thanks, John, for the questions. And I'd just like to address the second question and add on to what Dave Dinges has talked about, in that I think that competition is absolutely critical to the ensuring the most meritorious science gets supported, and that we utilize the precious resources on the station and really do the best possible science. And case in point, with the NSBRI's participation in the Mars 500 project, the peer review that was performed on the proposals that came in through an open solicitation that was actually held by IBMP, is the open solicitation. So those U.S. proposals that came in underwent the same rigorous peer review that any other proposal would have. We made sure that there was excellent representation. In fact, there was an international peer review committee. I think that in addition to that, what happens on these more complicated international collaborative activities, similar with station and in other areas as well, is that you have to ensure that the science is operationally feasible given the constraints of the environment and the other experiments and the confounding variables that take place, as well as the fact that that the science is accepted in terms of the peer review and the merit that's done in that with the other nations. So it's actually even more rigorous process in our limited experience than the rigorous process that one goes through for an NIH or individual NASA or NSBRI supported grant application.
Thank you for the question. I would say that it is what we discussed here. Collaboration should surely is not jeopardizing anything of a very important things like competition and repetition. I think those are in the blood of each team research. You can't avoid that. You can't demonstrate anything without repetition, and the best thing come up from competition. So I don't think there is any reason to believe that this kind of collaborative issues may touch in any way this. Let me say that the only thing, just again, from the international standpoint, I would not like, personally, I don't like the idea of seeing repetition between an American experiment and a European experiment and a Russian experiment. I love to see 3 repetitions between joint experiments of different teams. Of course, a peer review is the most important part, and actually I know that a lot of discussion about peer reviewing is going on right now in the world scientific community, which is, hot issues right now. So probably something, like this might be also the subject of some talk, even in this kind of summit, because it's a very important thing to do. And if things are going to the international, view, this peer reviewing is going to be more difficult to do in a correct way, of course. So this is something that we must. Thank you.
Okay. And yeah, okay.
One thing that I would like to talk is maybe the definition about the research, the basic research and operational medicine, maybe different people use different definition to discuss. So that's why I think a little bit confusion happens. That's what I have learned based on the previous speakers and also the last year's the comment. And like for example, the basic research, the priority of the basic research is like John mentioned, the competition, creativeness, and uniqueness, and seek the originality. And then the operational medicine is the one that we need to we can force them to work together. We as agency people to force them to work together to standardize the method and also the share the medical data. And then yesterday I realized, like Rupa, you mentioned that the countermeasures experiment is in the kind of difficult area to understand. Because like, for example, my case, the countermeasures experiment is very close to the operational medicine. And then the Rupa, yesterday you mentioned the countermeasures. The German side still try to understand the mechanisms of the countermeasures. So which means you think the countermeasures experiment is very close to the basic research experiment. So the first, I think we have to maybe define we have to, when we talk about this collaboration, maybe we have to define the word of the basic research versus operational medicine. That's one thing. So, and then the repeat, as you mentioned, the repetitiveness of the international countries is a kind of different issue. And then once we somehow select maybe like international announcement of opportunity, that mechanism or framework is the one that we can make that the repetitiveness will be avoided during that kind of situation. But first, we have to respect the scientist idea. If the scientists propose to the basic science, then let them compete, let them seek the originality. That's what I think.
Okay, and what I'll do is I'll probably maybe take one more response, and then we'll try to get another question so we can broaden our scope of what we're talking about, because we don't want to spend all our time on one question.
I would like to clarify a little bit our scientific program and our approach to the Mars 500. Of course, here there is definitely an element of competition present. The most important thing that this is a delicate subject. It's important to treat it in a sensitive manner. And such an issue can only be resolved by high-class specialists who can give a true assessment of the proposals that are submitted and also their meaning and their feasibility and their repetition and the possibility of the implementation of those proposals. So one has to say that Mars 500 did not include far not all, very few of all the proposals that were submitted. 104 were submitted and only 30 experiments were accepted among those that were proposed by our foreign.
If you allow me, I have two questions.
Sure.
One is a typical psychological question. How will you evaluate the influence of administration and agencies on collaboration? Do they just do not prosecute collaboration? Do they say, give us moral support, like, do it, please, we are on your side? Do they give priorities to the collaboration, or do they fund collaboration? This is the first question. And second question is also a very short one. It seems to me that we are more supporting, let's say, names or labels than problems. For example, moon problem, then it could be Mars problem, then it will be ESS problem. As far as I understood from the talks today, it seems that if agencies will support the analysis and the investigation of problems, that will be long-lasting international problems. If it will be the supporting of labels like Moon or Mars or something, that will be a political, let's say, event which will be changed by some other event with another structure, another participants, another funding. And it seems to me, correct me if I'm wrong, but that now it's more like this, like political support. Thank you.
Okay. Yep. Jeff? I'll take a crack at the second question. I agree with you. I think one of the reasons we're trying to finish the 65 human system risks and publish them, get them out into the community, is their platform and mission independent. You can look across those risks and decide which ones apply to a particular flight, from suborbital all the way up to a Mars mission. So I think that gets to your point about, how do you allocate the work and what are you focusing on? Medical, environmental, human factors questions are going to be pertinent to any of those missions. So you could focus on the work. I think that also ties back to the first question, because in terms of collaboration, because the way we look at the risks from standards down to deliverables, different agencies may have different expertise along that continuum and could collaborate along the continuum of that risk, not necessarily on the same project, but still contributing to that overall risk. So, thanks.
Okay. Any other, anybody else want to talk about some of these things?
Bill, I'm sorry.
Go ahead, Jack.
Could I make a comment just
Sure.
from an historical point of view, since I've in various roles as a lead scientist or lead for the HRMRB or whatever, followed these activities for many, many years. And historically, when we were getting started, what we had was individual programs from each agency. And so, for example, even I can remember many discussions in the ISIL-SWIG framework where ISO at that time wasn't doing human research, but they said basically, look, we've got a backlog of, at that time it was hundreds of experiments that they had the responsibility of flying. And we had our own program where we were doing solicitations and trying to select the best human research to go. Russia had its own program. And even as we got into station, one of the things that we dealt with in the HRMRB was we had a Russian program which in many ways duplicated some of the same measurements we were making in the U.S. program. All of that was okay as we were evolving station, but now we're at the capability where we can really do significant research. I don't think that's okay anymore. I think it's up to the management to set the priorities and to do truly integrated international studies. We have such limited resources, whether it be money or human. And so I really support that. I think it's extremely important. We can no longer have a Russian study or an ESA study or a NASA study. It's just not practical.
Okay. Good. Yeah.
And just to add on to this point, I think we've agreed that we all support and all the partners support collaborative work together. Unfortunately, there are some obstacles to do collaborative work. And the challenge that we have is to establish the tools that will allow us to do this collaborative work. I think Dr. Sutton made a good case where he explained that federal monies could not be transferred to the isolation study, but it was a workaround. So our approach is to, from what we've done so far, we've established some strategic MOUs, one with an SBRI, that will give us a mechanism by which we can collaborate on some of the health risk issues. We, as Canada, we are a state member of ESA, and therefore we can also collaborate and apply to some of the AOs that are international AOs from ESA. We work closely with our Russian colleagues through contractual arrangements or agreements to collaborate in some of the research projects. So there are tools, and our mandate is to make sure that we think outside the box to create those tools and then to integrate all these tools so that we can better collaborate together.
Okay, yes.
One question about the history. Since Chuck mentioned about the history, ISRUS, the framework is the one that usually we talk about the international collaboration. But I've always wondering why Russia is not a part of the ISRUS.
Yeah, okay, Chuck, you go ahead.
Maybe everybody, if everybody knows, then I will ask about it personally. But if we talk about the international collaboration, big countries like Russia and the USA, and ISRUS is the highest framework for work together.
We're talking about ISLSWIG, why Russia was
Yeah.
not a participant.
It's not, yeah.
There were, and Essa will certainly have her thoughts. And mine were, there was very limited money available in Russia at that time to travel to these meetings. The meetings were held all over the world. That was one thing. Second thing, Russia generally, even as you've heard today, their philosophy was bilateral agreements rather than group agreements. And so they'd been very successful for many, many years having bilateral agreements with NASA or whoever. Those were a couple historical reasons that I'm aware of.
But don't you think that it's now time to be a member of the ISRUS? Like, if we think about the international integration or collaboration,
international board,
we really need US
No.
and
Let me tell you. I think that there is somehow. It is to my surprise showed that this discussion showed that absence of experience in some people who do participate in collaboration, but they don't know, this way or the other way it is organized. I don't understand why do we have to say today or competition or not competition. It should be both. It should be both. If we collaborate, it doesn't mean that we take whoever it is and whoever he is doing. The competition is there. So the problem is, that's why yesterday I was talking about the management, that management doesn't have to rule, but management has to organize. And we are waiting for this organization. Otherwise, we can do, like scientists can do, give him money and he will do whatever you want him to do, he will do it. But if you want us to collaborate, then organize it, because it needs coordination and organization. And we didn't have any difficulties with organization. That's what I wanted to say, and I just wanted to say I cannot, because I understand that it's not ethical. But I would like to say, okay, then let us make meetings of managers when they will, without scientists, they will exchange experience. How did they made this or that organization, and which organization was successful, which was not? Because let me come back to Mir Station, or not Mir Station, maybe more now will say something. Like, we didn't have collaboration, but we did have our astronaut. Astronaut came back, and every agency wanted to study. What did they wanted to study? Not just everything. They wanted to understand, what what disturbances do they have from flight? Disturbances in locomotion, not anything. Maybe some peculiar scientist knows something what he wants to see, but all of them wanted to see mechanism of locomotor disturbances, posture disturbances, vestibular disturbances, and so on. Space leads us what to look for. So what's happened, that I remember very well when Tolia Solovyov, he was running locomotion tests with me, and he asked me, he said, Inessa, I'm running on the 3rd floor with you, then I go to the 2nd floor and doing locomotion again with Isa, and then I go to the 1st floor and do the 3rd locomotion. This locomotion with French, because that is different, French, Isa, and we. And he said, do you think it is healthy for me to run 3 times. You know, maybe it would be better if you will get together and I will run once for all 3 of you.
Inessa,
And
this is what I was talking about yesterday. Exactly this point. When you try to pack these analogs with 50 or 70 experiments, you don't tell the individual investigators of what else is going on, and then you find out later your data's been corrupted because you had people doing other things.
Yeah.
If we don't fix that, frankly, good scientists aren't going to do this because we don't want to do bad. The only thing we care about is really good science. And if it's going to be methodologically sloppy, we don't want any part of it.
No, but for this, I should be informed first of all. I should be informed first of all. Who is doing what on that side of the world? This is the first thing. The information, we were talking about obstacles. I didn't want today to talk about obstacles, but actually one of the obstacles, it is information with, how to say, lack of information. Lack. We don't know what is planned there, on here, and so on for this particular mission, for future mission. And one thing which should be done and which should be established, it is information, very current information exchange between agencies, institutions, and so on and so on. That's for sure. But the other thing, I'm sure that leading, is very important. And it exists, what we are talking about. It does exist because because I say that we are not in free world, we are in space science, space medical science world. So then for different mission or for different program, we say what is the purpose. And it was always, the purpose of study genetic, genetic factors in development of this or that. So the people who don't do genetic, they will not apply. But people who are doing genetic, they will apply. They will apply, and there will be competition of those projects which were applied. What's the problem now? And it will be on your side, on my side, and on US's side. Then when selection is done, there, then those people who are selected, they get together. That's how Bion was done for 30 years, and they do very well. Of course, they discuss, they insist, and then something common from 3 of them come out, and that's it. So selection, good selection on your side. Why I'm saying so? Because I was in this situation. I remember the situation of selecting program for monkey, and we knew that we are ordered to do motion sickness study with monkey. I mean vestibular, and our people, our board decided that we have to have this question analyzed. So we gave it to American agency, saying that we are looking for receptor, scientists, reception scientists, for those scientists who are working on velocity storage, for those scientists of this and this and this. And they have done it on their side. And I knew in advance that for velocity storage, Dr. Cohen will be selected. He was the creator of the theory, right? And for receptor study, they were selected. Okay, they were selected Manning Kareev. He was one of the best. I didn't select them from here. You selected them on your basis of concourse and so on and so on.
Okay.
But the general line, the general purpose of the program were given by us. That's it.
Okay. See, one more, and then we'll.
Yeah, I think the discussion has really sort of evolved, and from Chuck's comments and Chiaki and on the Bion and Mars 500, we certainly have some really good models as well as the CERN, Collider and, of course, Hubble Telescope Institute. And what they do is they put out, requests for proposals for the Institute, and then people from all over the world, scientists from all over the world apply. And since the Hubble Telescope time is just as valuable as ISS, so they make it a worldwide resource so that you don't have to be in the European Space Agency to actually apply for the Hubble Telescope research. And I don't know how it's done in Switzerland and how that's managed. We probably have some folks here that have a better understanding on how that's managed, because again, their time on that facility is really limited and costs a lot of money. So, following up, I think you all are actually coming to sort of a nice conclusion that maybe the ISS, now that we're in utilization, should be handled like the CERN facility or the Hubble facility, or maybe even some of the others. Those are, of course, Hubble is truly owned by the United States. Bion is truly owned by Russia, but I don't know how the Switzerland facility is owned. But, we need to look at this as an international facility that people compete for, and then we put it together. And I don't know, that would change your organizational structure, and I don't know how that works with governments, but I think that's where you're going, is that kind of a conclusion where it's a facility for the world and people compete, and then you coordinate, and it would change your structure. But I think that's where you're all going in this discussion. Thanks.
Okay. So I think what I'll do is I'll kind of wrap up a little bit, since I get to be moderator, and I'll get to say a few things here at the end, and then we'll wrap this up. I think, I listened quietly to all the discussions, and a couple things I picked up out of this is I think I totally agree it's not competition versus collaboration. It is really going to be some mixture of both. That has to be there. It cannot be one or the other, and that's a wrong thinking if we think it that way. Another thing that we talked a little bit about was what's the agency role in collaboration, right? And could the agency be totally passive and collaboration will occur? That isn't going to happen. Can the agency be totally active and provide funding to stimulate collaboration? I don't think our governments are magnanimous enough and generous enough to look at funding other countries to go do work, so I don't think we can fully take that active role. That's probably the other extreme. So we're probably somewhere in the enabling region where we as agencies and managers can do things that enable collaboration and put a framework and structure in that researchers are rewarded for collaboration, they're rewarded for working together, and by rewards they're maybe not financial, they may be more opportunities to do research on station, they may be financial, they may be time, they may be investigations, they may be ability to present at certain conferences. We can figure out a way from a management side to enable cooperation with rewards that pull the team together. The other thing I heard pretty strongly through this was that we need to think of station more as a total facility or a total utilization of station. That's easy to say, but very difficult to implement. The Hubble example works somewhat well because it's all the astronomers and astrophysicists are working on Hubble. It's within one discipline. The problem with station is it's also multiple discipline. It's not only this group in life sciences as program manager and AA, I see all the other disciplines as well. I see the engineering groups competing for the same resources you are. I see life sciences, I see physical sciences, I see materials, I see processing. So to then broaden that up to how we utilize the entire facility in a collaborative manner is going to be a lot tougher. But I think we need to head towards that model and try to break down some of those walls and build some incentives to get agencies to work together, at least within disciplines. But I think we need to think about how we collaborate now, not only within our discipline, but how do we collaborate across disciplines. So that was another thing that I picked up. I think the other probably our thing we discussed a little bit was, do we treat this as problems we're trying to solve, or do we treat them as labels, was the discussion. Is it Moon, Mars, or Leo, or beyond? I think, again, the answer is neither one of those. It's a combination. We need to identify the problems that we need to solve, but if we just talk about those problems and we don't talk about them in context of a larger mission, they're lost. So we need to talk about, we're going to solve bone loss potentially for Mars experiments, for maybe near-Earth objects, for lunar things or whatever. So there needs to be a mission focus that we talk about, not a singular mission focus, but a multiple mission focus that these problems are addressing. because I think we get lost if we just stay with the problem aspect and we don't tie it to some mission, but we don't have to tie it specifically to that mission. So therefore, someone in Russia can talk about how this problem is supporting their mission and activity. Someone in the U.S. or NASA can talk about how this problem is supporting our activity, and they may be very different activities. And I think that's another approach. The other things I picked up a little bit overall out of the whole discussion was, yesterday at lunch I wrote down the things that Huda talked about in terms of cooperation or collaboration, and the things she talked about, and you guys have said them all in various forms throughout the day today, but there are things like trust. There has to be that trust that comes about from working together. I talked about it in my talk a little bit yesterday. That trust is gained over time. You can't immediately trust everything all at once. That's just not human nature. You're going to have to do that through relationships. You have to do that through communications. You have to do communications both formally and informally, so you gain those experiences. There has to be honesty, she talked about. Generosity is there. You have to be willing to give up some things, give up some authority, some control. That's a big deal. Fairness, credit. Make sure that you've understood the constraints up front about who gets credit. She talked about that yesterday. That's extremely important, and that's a piece of communications. And then the last thing was chemistry, that folks work together. So I think we've got a lot of good frameworks here. I think what we need to do now is to get kind of out of writing these down, and we need to take some small steps, not take the big picture, but take some small things that we think we can actually implement, challenge ourselves to come up with one or two things, very small, not the big statements from last year, but even parse that down into one or two things that we think by next year when we come together, we can actually say we're making some progress in this direction. And hold us in that account. And I think what Jeff is doing through some of his work is a good way of doing that. He's thinking of these things as problems. He thinks of them at risk. He's starting to put together a framework to try to work that cooperatively. Now we've done that. Now can we start doing the next step, which is actually assign problems to someone else to let them go work them. And that's the recognized leader. Then that leader can get support for that problem from whoever they need to get support from. So again, I think this has been a very insightful thing for me. I sit at the Multilateral Control Board kind of above all the fray a little bit, and we've recognized that we really need we have a finite opportunity to utilize station here in this next period. Collaboration and working together is going to be key to that. We don't have a lot of time to go invent new things and new processes. We need to figure out a way to kind of take what we've got, move some small steps forward, and move expediently towards getting the maximum use out of station. So hopefully you learned something today. I sure learned a lot over the whole time frame here. And again, thank you for your attention to this session.
That was excellent. Your presentation was good. With this at the end,
that's what we've got to. That's the single most important thing. We need to get the Japanese scientists, the American scientists need to get together. We need to look for common opportunities. It could begin with first just being aware on paper of who's doing what.
Almost 8 years and really, this is about to turn.
Yeah.
Triple it.
So, the talk yesterday at lunch.
Right. That's a good idea.
Not for me. I know all that. That's what I do already.
Yeah.
Collaboration. I already have 7 international collaborations. That's for people who don't understand how science works. That you got to have this understanding of each other. What she didn't say up front was that she knew this person. She'd seen his work. She respected the quality of his work, and they were working on a similar problem.